each of these limit has x goes to infinity. The technique in finding this limit is you have to find out the highest degree, the exponent in the denominator. So for example, the first function, we have 3x plus 7 divided by x minus 4. So the highest degree in the denominator is 1, right? So the technique is you have to divide the top and bottom by 1 over x. That means you take each term, 3x, 7x, and minus 4, you have to divide by x. And then the next step is limit as x approaches to infinity. Oh, always start with an equal and a limit. So you have 3x divided by x plus 7 divided by x, and then x divided by x minus 4 divided by x. So you have limit as x approaches to infinity. The top you have 3 minus 7 over x, and then 1 minus 4 over x. So once the x goes to infinity, the 7 divided by infinity and the 4 divided by infinity, they are just a 0. And then the next line, 3 divided by 7 over infinity, and then 1 minus 4 divided by infinity. So those two fractions are just 0, right? You take 7 divided by a huge value. So 3 minus 0, 1 minus 0. So the answer is equals to 3. Okay, so that means y equals to 3 is a horizontal asymptote. So y equals to 3 is a horizontal asymptote of the function. All right, so moving on to the next problem. The next problem, the highest degree in the denominator is 3. So we have limit as x approaches to infinity, 7x to the third plus x squared minus 6 divided by 10x to the third plus 1. I don't care what's on the top because in the numerator, I can have a 0. In the denominator, I cannot. So this one, let's go ahead and then divide each term by x to the third because this is 3. All right, 1 over x to the third. And then we write the next line, always start with limit x approaches to infinity. You have 7x to the third divided by x to the third plus x squared divided by x to the third, 6x to the third, the whole thing divided by 10x to the third divided by x to the third plus 1 divided by x to the third. And then you have limit as x approaches to infinity, 7 plus 1 over x minus 6 over x to the third divided by 10 plus 1 over x to the third. So once x goes to infinity, all the fractions become 0 because you take a real number divided by an extremely large value, you will just get a 0. So overall, you have 7 plus 0 minus 0, 10 plus 0. So the answer is equals to 7 over 10. I know you want to do a what if. So the thing is, what if this is a what if you divide each term by x to the fourth? So what if you have x to this divided by x to the fourth plus 1 divided by x to the fourth. So in that case, you will have 10 divided by x plus 1 divided by x to the fourth in the denominator. Once x approaches to infinity, you have a 0 plus a 0. Then you have a 0 in the denominator. Can you have a 0 in the denominator? I don't care what's in the numerator. Can you have a 0 in the denominator? The answer is no. That's why when you divide each term by what degree, you have to check out the denominator. Do you see this in red? Divide each term by the variable raised to the highest degree in the denominator. So the number that you are looking for is in the denominator. All right, so that's number 2. And then moving on to number 3, I have 5x to the fourth plus 2x. Oh, actually, you know what? I can just go ahead and then copy this and then bring it down here. So I don't need to copy this problem again. And then this problem, we have x to the third, right? So this is the highest degree. This is the highest degree. And then this is 1 divided by x to the third, 1 divided by x to the third. The next line is limit as x approaches to negative infinity. 5x to the fourth divided by x to the third plus 2x divided by x to the third divided by x to the third divided by itself, 1 divided by x to the third. And then we have limit as x approaches to negative infinity. We have 5x and then plus 2 divided by x squared, and then 1 minus x to the third. So this, the fractions, you have 5 times negative infinity, right? And then divided by 1, and then this is a 0. This is a 0. So you have a negative infinity divided by 1. As even though you have a negative infinity divided by 6, you still get a negative infinity. For limit, once the result is infinity or negative infinity, you say that the limit does not exist because we are not able to determine what y approaches to. So if this is not a real number, then you say the limit does not exist. All right. Moving on to the last problem. So the last problem looks very complicated because the rational function is big. So what is the highest degree in the denominator? The highest degree is the 7. I don't care what's on the top. So this is, you have to multiply 1 over x to the 7, 1 over x to the 7. And then the next line, always start with limit. I have said this like 100 times. X to the 5th divided by x to the 7. Take each term divided by x to the 7 minus 12 divided by x to the 7. I don't really care what's on top. 0, I'm fine with that. X to the 7 divided by itself. 2x to the 4th divided by x to the 7. 1 divided by x to the 7. And then limit as x approaches to negative infinity. The denominator, I have 1 minus 2 divided by x to the third minus 1 divided by x to the 7. The top we have x, not x, we have a 1 divided by x squared minus x, x to the, not x, I keep saying x, 1 divided by x to the 4th plus 6 divided by x to the 6th minus 12 divided by x to the 7. Let me make sure I got everything right. 2, 4, 6, and 12. All right. So once x approaches to infinity, all the fractions become 0. So 0 minus 0 plus 6 0 minus 0 divided by 1 minus 0 minus 0. So I can have 0 on top, that's fine. So we have 0 divided by 1, so the answer is equal to 0. All right, again, it is okay to have 0 in the numerator. And other than the highest degree in the denominator, one thing that I have been saying all the time is you have a real number. So let's say you have a 5 divided by negative infinity, you get a 0. If you have a 10 divided by positive infinity, you also get a 0, as long as you have a number. 5, 10, 16, 17, 100, 105 divided by infinity, that is just equals to 0. So use on your calculator, just try this. Take 5 divided by 99999. You are going to get a number that is not exactly 0, but is very close to 0. All right, that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, subscribe to my channel if you are on your way out. I will catch you all in the next one. Signing off for now.